Namaste to everyone. I welcome you all in my YouTube video channel. Today, I will deliver lecture on ring theory, lecture number 6, in which I will give the details knowledge of units in a ring. Now, we define unit in a ring. Let R be a non-trivial ring with unity. Then an element A belongs to R is said to be a unit if there exists an element B in R such that A multiply B equal to B multiply A equal to unity I being the unity in the ring R, and B is said to be multiplicative inverse of A. Here we should know the difference between unit and unity. Unity I in ring R means any element A belongs to R such that A multiply I equal to I multiply A equal to A. And unit means an element of the ring which has multiplicative inverse. By examples, we will try to clear this concept. In a ring, the set of rational numbers Q with binary operation, addition and multiplication, each non-zero element is a unit. In the set of rational number, unity be 1. 1 be unity. Since 5 belongs to Q and 1 by 5 also belongs to Q, means 5 is a rational number and 1 by 5 is another rational number, and their multiplication 5 multiply 1 by 5 equal to 1 by 5 multiply 5 equal to 1. Therefore, 5 is a unit because here we have 5 and its multiplicative inverse 1 by 5, their product equal to unity. 1 means unity here. Next example, in a ring Z6 with binary operation, addition and multiplication, 1 bar and 5 bar are units. In Z6, unity be 1 bar. 1 bar be unity. And 1 bar multiply 1 bar equal to 1 bar. Therefore, 1 bar is a unit. Its multiplicative inverse is 1 bar. 5 bar multiply 5 bar equal to 1 bar. This is the unity. So, 5 bar is a unit. Its multiplicative inverse is 5 bar. In example 3, Z5 with binary operation, addition and multiplication, each non-zero element is a unit. In Z6, each non-zero element is not a unit, because if we take 4 bar belongs to Z6, we may not get any element X bar belongs to Z6 such that 4 bar multiply x bar equal to x bar multiply 4 bar, and this not equal to 1 bar. We may not get any number. If we put here 1 bar, then 4 bar multiply 1 bar is 4 bar, not 1 bar. If we write here 2 bar, 4 bar multiply 2 bar means 8 bar means 2 bar. So this is not unity. If we write here 3 bar, 4 bar multiply 3 bar means 12 bar means 0 bar. Remainder 0. So we may not get multiplicative inverse of non-zero elements of Z6. So only two members 1 bar and 5 bar are units in Z6. But in Z5 each non-zero element is a unit. We may get this as 1 bar multiply 1 bar equal to 1 bar, 2 bar multiply 3 bar equal to 1 bar, here 6 bar. If we divide 6 by 5, remainder is 1. 4 bar multiply 4 bar, 16 bar. If we divide 16 by 5, we get remainder 1. So this is 1 bar. So 1 bar, 2 bar, 3 bar, 4 bar, each elements be unit. That means each non-zero element has multiplicative inverse. So unity be an element of a ring such that if we multiply any element with unity, we get that element. But unit in a ring is an element such that it has multiplicative inverse in that ring, then that element will be termed as unit. Now we prove a theorem. If A be a unit in a ring R, then its multiplicative inverse is unique. Let, if possible, B and C be two multiplicative inverse of A. Therefore, A multiply B equal to B multiply A equal to I, unity. This is number 1. And A multiply C equal to C multiply A equal to unity. This is number 2. Now, B multiply A multiply C by associative law, this equal to B multiply A multiply C by associative law. Implies that B multiply A multiply C is unity. This equal to B multiply A is unity multiply C using 1 and 2. Implies that B equal to C. So, if we consider that B and C be two multiplicative inverse of A, then B equal to C. That means they are not distinct. So multiplicative inverse of A is unique. That is one and only one. Proved. Now we prove the next theorem. Next theorem is, if R be a non-trivial ring with unity I, then 0 not equal to I. Means 0 element of a ring is not equal to unity of the ring. Given that R be a non-trivial ring with unity. Non-trivial means there exists at least one non-zero element. A belongs to R, ring R. And we know that A multiply 0 equal to 0 multiply A equal to 0. This is number 1. And A multiply unity equal to unity multiply A equal to A. This is number 2. If possible, let unity equal to 0 implies that A multiply unity equal to A multiply 0 implies that this is A multiply unity is A, and A multiply 0 equal to 0 using 1 and 2. Here we have considered that A be a non-zero element. Here 0 element, A is 0 element, which contradicts our assumption. That is, here A is a non-zero element, here A is 0 element. If we assume I equal to 0, unity equal to 0 element, then we get A equal to 0 element. That means our assumption is wrong. Therefore, our assumption I equal to 0 is wrong. Therefore, I not equal to 0. Proved. Now we prove the next theorem. Next theorem is, in a non-trivial ring R, the 0 element has no multiplicative inverse. Now we prove this. Prove. Let R be a non-trivial ring. Therefore, there exists at least one non-zero element. A belongs to R. Since here given that the ring is non-trivial, it has not been given that R be a ring with unity. So, we have two cases. Case 1, let ring R be without unity. Without unity means there is no unity element in R. So, there is no question of inverse of any element, because if we take any element x in ring R and y be its inverse, then x multiply y equal to unity and y multiply x equal to unity. But unity is not an element of R. So here we may not take that x multiply y equal to unity in R. So there is no question of existence of multiplicative inverse in this case. Therefore, no element will be unit. Since 0 is an element of this ring, so 0 is not a unit. Proved for case 1. Now we take case 2. Let the ring R is with unity I. Therefore, unity I belongs to R. If possible, let 0 be a unit in R. Unit means this element has multiplicative inverse in ring R. Let 0 inverse be the inverse of 0. Therefore, 0 multiply 0 inverse equal to 0 inverse multiply 0 equal to unity. From the definition of inverse or unit, let this is number 1. Since 0 be the 0 element of R, therefore for any A belongs to R, we have A multiply 0 equal to 0 multiply A equal to 0. This is number 2. Replacing A by 0 inverse in 2, we get 0 inverse multiply 0 equal to 0 multiply 0 inverse equal to 0. This is number 3. From 1 and 3, we get I equal to 0, because in 1 we get 0 multiply 0 inverse equal to 0 inverse multiply 0 equal to unity, and in 3 the same thing, and right side is 0. Here right side is unity I, therefore I equal to 0, which is not possible, because we have already proved that unity not equal to 0. Therefore, our assumption that 0 be a unit is wrong. Therefore, 0 is not a unit in ring R. Our assumption that 0 is unit is wrong. That means 0 is not a unit. Therefore, 0 has no multiplicative inverse. If 0 is unit, then 0 has a multiplicative inverse. But here 0 is not a unit. That means 0 has no multiplicative inverse. Proved. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and to subscribe my YouTube channel. Thank you.